be talking about the review sheet. So topic 1, part 1, review sheet that was assigned today, which is Friday. Your quiz over 2-1, 2-2, and 2-3, which is unit rates, and then also equivalent ratios is on Monday, February 22nd. So this is just a step-by-step of how to do each one of the problems, what you should expect on your a version of this will be on your test on Monday. So for the first part, it says for A through D, circle yes or no to tell whether each rate is a unit rate. So again, remember, a unit rate has a denominator of 1. Okay, we're looking for 1 unit. So 1 of something. So 1/8 of a cup to 1 serving. That is yes, because you can see that there is a 1 in the denominator. $1 for 1/8 of an ounce. That is not a unit rate because we only have 1/8 of an ounce, not 1 ounce. 6 students for 1 teacher. Yes, because it's a unit rate of 1 teacher. And then 1 truck, 6 wheels. That would be no, because there is a 6 in the denominator. So again, unit rate. Has a denominator of 1. So number 2, Jill is writing a book. It took her 1/5 of an hour to write 3/5 of a page. How fast is Jill's writing in pages per hour? So if it's pages per hour, that's our ratio. Page to 1 hour. Okay, so how much can she write in 1 hour? We know that she writes 3/5 of a page in 1/5 of an hour. But I don't want 1/5 in an hour. I want per hour. So I want 1 hour. So to get from 1/5 to 1, I divide by 1/5 in my denominator. And whatever I do in my denominator, I have to do in my numerator. So 3/5 divided by 1/5 is 3 pages. So Jill can write 3 pages in 1 hour. Okay, so for number 3, Bob knows he is 4 miles from the park. So change this to the park. On your papers, it already says, on the majority of your papers, it already says the park. I had to change it from first period to the rest of the class. So Bob knows he is 4 miles from the park. The map on his phone shows that the park is 3/4 of an inch from his current location. If Bob's location is 4 inches from home on the same map, how far is Bob from home? Okay, so some important information that we need to recognize in this problem is that Bob is 4 miles from the park. And on the map, that shows that the park is 3/4 of an inch from his current home, or his current location. He's 4 inches from home, and we want to know how far he actually is from home. So what I do is I draw myself a map. Okay. I put Bob in the middle. I know that Bob is 4 miles from the park. So he's 4 miles from the park. I also know that on the map, the park is 3/4 of an inch from where he's from. We also know that Bob is 4 miles from home. Or sorry, 4 inches from home. We want to know how far this actually is on a map. So our ratio here is 4 miles corresponds to 3/4 of an inch. So 4 miles corresponds with 3/4 of an inch. But I want to know how much 4 inches is. Because I cannot go easily from 3/4 to 4. I need to make a pit stop. I need to go to home base first. So by scaling up to 1, I can scale up to 4. So to get from 3/4 of an inch to 1 inch, I divide by 3/4 in my denominator, and I also divide by 3/4 in my numerator. 3/4 divided by 3/4 gives me 1. 4 miles divided by 3/4 gives me 5 1/3 miles. So that means on my map that 1 inch corresponds with 5 1/3 miles. But I don't want 1 inch because my home is 4 inches away from where I am. So I need to multiply my denominator by 4 and my numerator by 4. 1 times 4 is 4. And then 5 1/3 times 4 is 21 1/3 miles. So that tells us that Bob is 21 1/3 miles from home. That's a lot like one of the homework problems that we did. Again, going from a rate to our unit rate and then back up to another rate. Okay, number 4, Hillary's making a cake recipe that calls for 1/3 cups of cake mix for every 1/2 cup of water. How much water will she need if she uses 2 1/2 cups of cake mix? So our ratio is water to cake mix. I know that for every 1/2 cup of water, I need 1/3 cup of cake mix. So 1/2 cup of water to 1/3 cup of cake mix. I need to know how much water I will use if Hillary uses 2 1/2 cups of cake mix. Well, I can't get from 1/3 to 2 1/2 easily. So again, I need to make my pit stop at 1 cup so then I can go up or scale up to 2 1/2 cups. So again, getting to my unit rate to then scale up to my value that I need. So I divide by 1/3, divide by 1/3. So 1/3 divided by 1/3 is 1. 1/2 divided by 1/3 is 1 1/2. So for every 1 cup of cake mix, I use 1 1/2 cups of water. But I don't want 1 cup, I'm using 2 1/2 cups of cake mix. So again, I have to scale up one more time. So I need to multiply by 2 1/2 and multiply by 2 1/2. And when I multiply by 2 1/2, I get 3 3/4 cups of water. So Hillary will need 3 3/4 cups of water for 2.5 cups of cake mix. Alright, so number 5, using ratios, how can you determine if a relationship is proportional or non-proportional? Explain. So if a relationship is proportional, all ratios will be equivalent. Okay, to go into a little bit more depth, you can reduce each one of your ratios down to their unit rate. If their unit rates are all equal, that means that the relationship is proportional. A non-proportional relationship one or more ratios is not equivalent. So we talked about that a lot this week, where you have to test all of your ratios to see if they have the same unit rate. If they have the same unit rate, they're proportional. If you do the first two and you realize that 1 and 2 are not equal or not equivalent, that means your relationship is non-proportional. And then number 6, is there a proportional relationship between X and Y? Explain. Okay, so I did put this into a multiple choice question, yes or no, and then gives you examples. So no, all ratios Y over X are not equivalent. Yes, each X value and Y value increases by 2. Yes, the ratios Y over X are equivalent. No, all ratios Y over X are greater than 1. So we know from this part here that for it to be proportional, all ratios will be equivalent. For it to be non-proportional, one or more ratios is not equivalent. So that means from my table, I need to test the ratio of my X and Y values. Again, anytime I'm testing for a proportional relationship, I'm testing Y over X. And Y over X needs to have the same value or the same unit rate to make this statement true. So my ratios are 10 over 3, 12 over 5, 14 over 7, and 16 over 9. Okay, again, I want to get a unit rate for each one of my ratios. Comparing unit rates is the easiest way to compare your values. So to calculate your unit rate, you divide value to get to 1. So I'm going to divide with this one, divide both top and bottom by 3. 3 divided by 3 is 1. 10 divided by 3 is 3.3 repeating, or 3 3/10 repeating. So for this to be a proportional relationship, each one of these has to then be 3 3/10 repeating over 1. So when I go down here to 12 over 5, divide by 5 to get to 1, divide by 5. Whatever I do in the numerator, I got to do in the denominator because I'm making equivalent ratios. 5 divided by 5 is 1. 12 divided by 5 is 2 4/10. So right away, I've got 3 3/10 repeating and 2 4/10 over 1. My values are not equivalent. So that means I'm in a non-proportional relationship. So right away, I know that the correct answer is A. No, not all ratios are equivalent. You can go further and test the rest of them. Divide by 7, and you get 2 over 1. Divide by 9, and you get 1.7 repeating. So each one of my ratios, or each one of my unit rates, reduces down to a different value. That different value tells me that I have a non-proportional relationship. So there is no proportional relationship between X and Y. Okay. Study Kahoot is up. Enjoy your weekend.